Hey, Algebra 1, here we are again looking at section 2.5. I think now would be a good time to have a test after this section, so we'll talk about when that will be during class. We'll see, we'll discuss. But we're going to talk about solving equations involving absolute value. I do want to think a little bit about absolute value with you guys before we get into solving equations. I think you guys remember the definition of absolute value from last year. Absolute value of a number is just the distance from zero. So if I were to talk about, let's say, the absolute value of -3, hopefully you know that the answer was 3. Or the absolute value of 3, the answer is still 3. Why? Because if we're looking at the number line, and since absolute value is defined as a distance from zero, I hope that you all see that indeed the distance here from 0 to -3 and the distance here from, well, that didn't go so well. The distance from 0 to -3 and the whatever. The distance from 0 to -3 and the distance from 0 to 3 is exactly the same. So with that concept in mind, let's think about very simple equations with absolute value. So the first equation I'd like to think about is, I'm going to change my pen back to black. Get a better point. Okay, so let's say x were equal to, or the absolute value of x is equal to 4. What could x be? Most of you are pretty quick and you say, well, x could be two things, Dion, because it's either plus or minus 4. And you'd be correct, because if I had a positive 4 absolute value, the answer would be 4, or a -4 in the absolute value, and the answer would still be 4. So this little example, I hope you guys see, is going to be the basis of what we're going to be working on. When you have an equation with an absolute value symbol involving in it, you need to be aware that you're going to get more than one answer, or at least you have the possibility of getting more than one answer. Just as our, let me get my point back, just as our x here could have been either -4 or +4, when we solve even more complicated problems, we need to expect to have two different answers, or at least we need to think about the possibility of that which is inside the absolute value symbol being either negative or positive. Let's look at another example real quick. And by the way, I'm not expecting you to be copying this down. This is just us chatting. So what if I had x plus 4 is equal to 9? The absolute value of x plus 4 is equal to 9. Most of you right now off the bat are saying 5, but can you think of the other answer that this would be? The other answer, are you thinking about it? The other answer could be -13. Let's see. So if we already said that x could equal 5, because we know that x plus 4 equals 9 specifically says that I can subtract 4 on both sides, and x is equal to 9 minus 4, 5. You guys got that without actually doing work, I'm sure of it. But if we come over here and consider that x plus 4 did not have to equal 9, it could have equaled -9, because once I put the absolute value sign on both sides, it becomes positive. Now we get a different answer. So now we subtract 4 on both sides, and we get that x is equal to -13. So as we process through these problems, please keep in mind that absolute value, just the nature of absolute value, is going to breed more answers than we generally would expect in a linear equation. So example 1, expressions with absolute value. Here we have the absolute value of m plus 6 minus 14. What is the value of this if m is equal to 4? This is really straightforward and really something that I think all of you should be able to do. So 4 plus 6 is going to give me 10. Absolute value of 10 minus 14 is really just 10 minus 14. And I expect none of you to have problems telling me that 10 minus 14 is -4. If you like, you can do keep change, and do the whole thing. But 10 plus a -14 or 10 minus 14 is -4. Okay, so we get to the real drama here. Now this is where we have to solve equations that have absolute value symbols in it. So we've got f plus 5, absolute value of that is 17. We know that f plus 5 from our last discussion could equal 17, or it could equal -17, right? Because when I put the absolute value on the negative 17, it's going to make it positive. So it could equal positive 17 or negative 17. So we literally have two problems to solve. But then it says here, then graph the solution set. And so what that means is just put a number line down and put the points or the dots where your answers are. So 4.5 is equal to 17. 4.5 is equal to negative 17. Very quick solving. Subtract 5 from both sides in this first in this first equation, and I get that f is equal to 12. That's one possible answer. Or when I subtract 5 on both sides or add the negative 5, I get that f is equal to negative 22. And that's another correct answer. If you want light, plug it back in, check to confirm that you got the right answer. So where's our number line? What does that look like? Simply put, what we want to do is draw. Let me get rid of those arrows. Okay, draw a number line and simply put the values there. So that's negative 22 is one answer and a positive 12 is the other, and 0 would be somewhere here. I'm very comfortable if you do just that. And then when we are saying that a solution is verified, what we do is we actually fill a dot there. So that's what they mean when they want you to graph the solution set. Negative 22 and positive 12. This next guy is fun. You'll probably see one like this on your test. So the absolute value of b minus 1 is equal to negative 3. Somebody right now is annoyed with me because of this, and you should be. Absolute value is always going to be positive, and there's no way that it equals to negative 3, so this is somewhat of a trick problem. If you went down the path and did a b minus 1 is equal to negative 3, or b minus 1 is equal to positive 3, if you solve this, you would get that b is equal to I'm going to add 1 to both sides. B is equal to negative 2. Let me get that off. Negative 2 over here. And over here, B is equal to a positive 4. But when you plug those bad boys back into this equation, it doesn't work. It doesn't work at all. So the absolute value can never equal anything negative. So I'm going to scratch this out to say no way. And I hope you understand why. Because absolute value is defined as positive, and here we have it as something negative. So with this example 3, we have a real-world example where we're talking about absolute value. The temperature of an enclosure for a pet snake should be about 80 degrees Fahrenheit, give or take 5 degrees. We're going to find the maximum and minimum temperatures. I'm sure that you guys are really quick and you were able to go, oh, the answer is plus 85. Plus 5 gives me 85, and minus 5 gives me 75, and you're correct. That's it. But we're going to consider the concept of absolute value as we do this problem. So let's first look at a number line. So as you can see from this section of the number line that we have, the distance from here to here is 5, and the distance from here to here is 5, which is exactly what the problem says was acceptable in terms of the range of temperatures for the pet snake. However, what I want you to realize, and the answer is just what we said, 75 and 85. What I want you to realize is that there's a way that we can look at this so we can include the concept of absolute value. We know that the range of temperatures has to be, or the difference between the temperature and 80 has to be equal to 5 degrees, right? That's the maximum. It can be, the difference can be as much as 5 degrees from 80. And so here we see the absolute value of 80 minus x is equal to 5. We could actually solve this inequality to get these two answers. And we'll do that really quickly. Recalling when we solve inequalities that we get two different equations that we need to solve for. We've written them down there, and then we'll solve simply like this, and like this. So what we see is that when we have a number line problem, when we have a number line setup, when we're looking at values that are equidistant in either direction from a number, that's also an absolute value problem. Let's take a look at this next example. Sometimes it's really convenient to write an absolute value equation about something that you see like this. So in this problem, we're asked to write an absolute value equation about 11 and about what we see on the number line, 11 to 19, or 11 and 19 being a solution to a particular problem. So what we want to do is we want to consider, what is 11 and 19 equidistant from? And that number, hopefully you guys can see, is 15, because 11 is 4 spaces from 15 and 9 is 4 spaces from 15. So similar to the problem that we looked at when we made the last problem into an equation, an absolute value equation, we can see that the difference of 15, I can do x minus 15, the difference of 15 and this number has to be equal to 4. And if we solve this equation, we'll see that we'll get the two answers of 11 and 19. Again, here are the two possible things that can happen. X minus 15 is equal to 4. X minus 15 is equal to negative 4. When I solve for x in the first equation, I get that x is 19. When I solve for x in the second equation, I get that x is 11. So the answer would be this absolute value equation. Okay, guys, so your assignment is as follows. I think this is just exactly what we have printed on the front of the packet, so you should be fine. Definitely have a good day, and we'll talk about the possibility of a test this week tomorrow.